So alcohols, the next topic then, 2.7, they contain a hydroxy group, so an OH group. That's what makes them alcohols. Depending on where it's attached, depends on what type of alcohol that we have. Okay, so there's two ways to prepare ethanol, which is the most commonly used alcohol. So it's got two carbons, ethanol. One way is to ferment it. Okay, so fermentation using starch and an enzyme to make glucose. Glucose added to yeast will make ethanol. Okay, so enzymes break down starch to form crops into sugars, which can be fermented and distilled to form alcohols. This method is cheaper than hydration, which is the other method, can be carried out at low temperature. However, it is fermented in batches, meaning it's slow and there's a low yield. Okay, ethanol is a common biofuel produced in this way. It's considered carbon neutral because you make these from plants, so plants take in carbon dioxide, and then obviously when you burn it, you obviously release carbon dioxide, but the equates as like an equal amount of carbon dioxide. So with this process, it has to be distilled, so you need to know the basic makeup of a distillation. You need to be able to either label it. You might even be asked to draw it. Okay, so you've got condensers, your impure products, so two liquids tend to be mixed together, thermometer, condenser there with water coming in and out, and then a collecting tube. Okay, what happens is liquids tend to have different boiling points, so you boil them up, one should evaporate before the other, evaporate into this tube, then cold water causes it to condense and you can collect it. You need to be watching the temperature, because when the other one's boiling point appears, then you need to stop it, because you want to collect just a pure product. Okay, the other way then to make alcohols is to hydrate ethene, or because we were making ethanol, but you can hydrate any alkene. Okay, what you need, you add water, so it's like hydration, adding hydrogen. You need an acid catalyst. Okay, phosphoric acid is normally used, and you make a alcohol. Okay, because it's exothermic, in terms of Le Chatelier's principle, you need quite low temperatures, so quite low temperatures because it's exothermic on the end side, product side. So we kind of like a compromise at 300 degrees, which is relatively high, but not as high as some things, because if it was too low, wouldn't be any reaction. It would take too long. It wouldn't be viable. Okay. The other thing then we want to look at is we've got 2 moles because we've got two things. So, and there's no numbers in front of them. So 2 moles to 1 mole. This favours quite a low pressure as well. Okay, at 60 to 70 atmospheres pressure. That just links to Le Chatelier's principle. Catalysts have nothing to do with the principle, but just so you know. Okay, so a big thing that we use alcohols for is biofuels. So we get biofuel and biodiesel. We use them, well, they're hoping to use them in cars and stuff, but they're a little bit different in terms of how they combust. Okay, there are a couple of advantages though to using them over normal petrol and diesel. They're renewable, so we can grow whatever we're using again and make them again. And there's not as much CO2 release. So when we burn them, they still release CO2, but it's not as much. Okay. Also helps with economic stability in countries where they maybe don't have as much money or access to fossil fuels and they haven't got money to buy them. The price tends to be lower, so we could use them. Okay. Disadvantages: they use loads of land. Okay. You have to grow all the product before. Okay. So land use. They use large amounts of water and fertilizers, so it's a cost there. And then people say they're carbon neutral. So obviously they take in carbon when they're growing because they're plants, but are they completely carbon neutral? Because they do take quite a lot and release quite a lot of CO2 when they burn. So there's a bit of a debate about whether they're carbon neutral. So moving on then. So classification, nice and easy kind of topic. Alcohols are classified into primary, secondary and tertiary alcohols, okay, depending on where the hydroxy group is on their carbon chain. Primary and secondary alcohols can be oxidized. Tertiary alcohols aren't really that often oxidized. So to test for them, we use potassium dichromate. It's what we use in breathalyzers. It's an oxidizing agent, and it's reduced in color when the alcohol is oxidized. So primary and secondary alcohols will turn green in the presence of potassium dichromate. Tertiary alcohols won't. So it's a way of identifying that you've got alcohols. So if you are a primary alcohol, then you can be oxidized with acidified potassium dichromate, and if it's distilled, it will produce aldehydes. You can then move on and further from an alcohol, if you reflux it, using the same products or the same oxidizing agent, you can make a carboxylic acid. So alcohols can go alcohols, aldehydes, carboxylic acids. Ketones then are formed with secondary alcohols. Okay, it's the same kind of thing. Okay, acidified just potassium dichromate. Reflux it again, but this time alcohols, if it's a secondary alcohol, form a ketone. Ketones and aldehydes are noticed by their carbon-oxygen double bond. Okay, if it's a ketone, it's on the secondary carbon. If it's an aldehyde, it's on the final carbon. And then carboxylic acids are noticed by this group, their functional group C, double bond O, OH. So tertiary alcohols will undergo no oxidization. Carboxylic acids are a really weak acid. Okay, there's their functional group, I just talked about it. You can identify them by adding sodium carbonate. Should bubble off CO2 and the lime water should turn cloudy. Two things you need to know about carboxylic acids then. So in the presence of a strong acid catalyst and reflux together with an alcohol, carboxylic acids will join together to make esters. Okay, esters smell sweet, they're used in perfumes and food flavourings. What you need to know though is that the OH from here and the H from here bond together to make this process here. So you've got then the O double bond and just the O. So that's the H should have been attached there. And we label them, so the alcohol that's used is the first part of the name, so methyl, because it's methanol, and then the carboxylic acid uses the ethyrate. And finally, they can react as salts. Okay, and you need to learn these, so you might want to pause the screen here. They react with carbonates to form a salt, water and carbon, a bit like from GCSE. They also react with hydrogen carbonates the same way, like GCSE, and they can react with bases, so base, again like GCSE, to form a salt and water. Okay, but they're called carbonate salts instead of just normal salts.